Can you share my, can you see my
Yep.
RhinoCAM? Okay. All right, what I have here is, a triangle. I mean, Kelly told me that you guys are interested in looking at, some sort of triangle machining using a saw blade. And I looked at that video a little bit, and I kind of prepared this so we can go through this real quickly, and then we can also get into, the chamfer machining as well. So
Perfect.
So what I have here is I'll show you how to do the actual programming, but I'll show you first what I've done so far. So this is basically a triangle. Let's say we want to cut on these three sides using a saw and cut it off, and then come in with a aggregate head on the side, and you want to machine this, use pocketing or drilling like that. We can do that pretty easily. So our product in Rhino, it'll come in the RhinoCAM menu item will be added when RhinoCAM is loaded. And then you'll also, if you don't see this, you can turn on the browser by selecting the mill module here, and you see the browser. And the way our system works is you got this program tab where you're doing all your programming, and then you got the simulation tab where you're actually running the simulation to check the cut material simulation. And then there's other things I really don't want to get into, like tool libraries and all that. There's quite a bit of stuff in there. But
yeah, that stuff I feel like I can figure all that out on my own too.
Okay, all right. Yeah. Okay, so what you're seeing is this is the full 5-axis configuration that I have loaded here. So you'll see in our ribbon bar, in the program ribbon bar, you're going to see the 2-axis, all our tool axis methods, all our 3-axis advanced methods, 4-axis, which includes both wrap and true 4-axis, and then 5-axis methods, 5-axis continuous methods as well.
Yeah.
Okay, so the way you would use aggregate heads when you use programming aggregate heads, so we treat that as a 5-axis indexed operation. So let's talk about just creating a saw cut on the outsides of this triangle. So first thing I'm going to do is create like a stock box, which is basically, let's say that's the workpiece that I'm working with. I just created it with the offsets on the side so you can see the simulation. And then this is a standard setup. When I say standard setup, it means the tool axis, the blue arrow is my tool axis is pointing up. And then this is my first saw operation, which is basically I picked this curve and told the saw to machine on this side. And then I went around and picked those curves, which is basically the edge curves of that solid model that I created. So let's just run the simulation, and I'll get into how do you actually program it. So there's a single cut. It comes in and cuts that off. You can set up, cut levels if you want. You can, cut it in two or three, whatever, however more you want, depending on the material you're cutting.
Yep. And
this one is out of the box, so you don't need to do anything in terms of, index machining or anything like that, because if you look at our toolpath editor, the rotary axis is actually rotated by 180 degrees. So to come and machine this, so the system automatically figures out the rotation of your C axis. Okay, and then on the other side, it's very similar. I just selected the other one, simulate it, comes in, goes on the other side. Here, there is only a 90-degree rotation when it's machining that. You can see that in the P-axis down here. Rot axis is shown as 90 degrees. And let's look at the final one. I can make it go faster if I want. So, okay, cuts it off. Okay, and then as far as the aggregate machining, let's say we wanted to machine these pocket and this 2 drill holes on the side. So this is where it gets a little more complicated. So you need to create something called a setup. So the setup is basically telling the system which way the tool is oriented. So in the case of an aggregate head, you would probably rotate it by 90 degrees to come normal to this surface. So that's what I've done here. I've created this setup using one of these setup methods to create that. And the way you would do that is, you can just go select these surface, normal, and that gives me the blue arrow. Now it's pointing this direction, which means the tool axis is coming in that direction. That's what I want. And then I go select the, let me just delete this, I'll show you that. I can go to, let's say, pocketing, remove all, select curves. I got that curve created already. I created that curve. Select the curve as my drive geometry. And then I go to selection of my tool. I pick up my end mill. And then I want to cut that pocket maybe in a couple of levels. So I'm going to select my total cut depth. I can go and just pick on the model from the top to the bottom. It says it's 1/2 inch. I can go maybe, let's say, 2 cuts. So
Okay.
it creates the toolpath, right? And then I can simulate it. The tool's coming in this direction and machining it.
So it's just a 2-axis operation, but you're just picking which face it's normal
right.
to.
Yeah. So when you post it, when it's just set up, you're going to look at the primary axis rotating by 90 degrees, and then the secondary axis is also, there's 2 solutions for it. So it's outputting both solutions. So in the post, we can pick the solution that you want.
Okay.
And the same thing with drilling. I mean, you can do anything that you can do in the standard setup. All the 2.5 axis, all the 3 axis methods can apply in this rotated orientation.
Okay.
The same thing with hole making. So I can go drill. Select drill points. I'm going to select that. Right mouse click. I got those 2. Tool. I'm going to select my drill and cut parameters, and I can do the same thing for, drill depth is automatically picked it up because I'd already selected it previously. And I got my drill toolpath, so simulate that, then simulate this one. Okay, that's pretty much how you would do aggregate machining using aggregate, 2.5 axis machining, if you will. Yeah. And the post will take care of the setup and all that here.
Okay. Cool.
And the important thing to remember, though, one of the things we need to do is in the machine tool definition, we need to make sure you're defining it as a 5-axis machine with the head.
Yeah, and I was going to ask you would you guys help me get those initial parameters set up, or is that on us?
Yeah.
You would help with that?
Yeah, we can help with that. That's no problem. Okay. I mean, it's very simple, actually. All we're doing is saying it's 5-axis head to head. And then the most important thing is this gauge length. This is what we want to specify for the gauge length. And the gauge length is what tells us, how to compute the tool end. So we are programming this, right? So all this toolpath code is these points on the rotated coordinate system. But on your machine, the machine itself doesn't know you got a aggregate head stuck in the head, right? Yeah. So we need to compensate for the aggregate heads, dimensions. So that's what this does. When you go into the machine tool, this gauge length tells us, based on the orientation of my setup that I just created, and also the gauge length, it knows where to put the toolpath points, program points.
Yeah, and I'm wondering how we zero out our tool, because we don't, we have a tool sensor, like a touch-off probe sensor thing for all the other tools, but not for the aggregate head.
Yeah, so
it might work if you had it pointed straight down, but
yeah. So you'll point it straight down, and then you'll zero it out, and then you'll figure out the height, right? Height of which is basically the height from the touch-off point to your spindle face. That would be a gauge length, and that's what you input here.
Gotcha. Okay, so we just touch it off with it pointed straight down, and then we would rotate it if necessary.
Yeah, and you can rotate it any which way, and then we'll take care of the inverse kinematics for you, as long as we know how much to back off.
Perfect.
Okay. Yeah, that's once you do it once, then it's kind of set with the machine, so you don't need to keep doing it as long as you do the zeroing the same way. So.
Perfect. Okay. Thank you.
Okay, so that's pretty much it. This is how you program a very straight, simple, socket with the aggregate head, 90 degrees. So.
Yep. Yeah, that seems easy enough. It gets and I saw most of this in that other video.
Okay.
What I want to see is Yeah, like the saw blade
like
doing a
chamfer.
chamfer, and then
Okay.
maybe like a pocket in a chamfer or something like that.
With the saw?
Well, like maybe saw blade the chamfer, and then maybe like end mill pocket
Okay.
in that
I see.
chamfer. You know what I mean?
All right. Okay.
Or
So
something similar to that.
yeah, let me bring this chamfer part that I have it. Save that.
I mean, I guess with doing the pockets, it would be the same exact thing. You just be choosing.
You're right. Yeah.
So you don't even have to show me that, I guess.
Yeah. So all you have to, as long as you set the setup correctly, then pocketing is exactly what I showed you. 90 degrees or 45 degrees doesn't matter. So
yeah.
So let's just look at this one. So I've created some toolpaths already. So we got two chamfers at different angles. And then again, here, what we need to do, the important thing here is, how do we set up the orientation?
Yeah.
So let me show this to you so we can do it, and then I'll go back and run actually show you how it's done. So I picked that edge, and then I created a toolpath. Let me run it. So now you got the aggregate head rotated in a certain angle, and the tool is coming in that direction and machining that. Yeah. Okay, and then I go here, and then go in that direction. Okay, let me show you.
How are you setting the angle? Is it based on the workpiece, like selecting a face, or do you have to manually set that angle, or how does that work?
Yeah, let me show you how that's done. So I'll just go load the chamfer without the toolpaths, and I'll show you. Oh, it's already got the toolpaths. Okay. I'll delete everything. Okay. So let's say you got something like this, and you want to machine this chamfer, right? So first thing I want to do is create a setup. So I'll go create a setup. Easiest way for me to do it, select this surface and say my tool axis is normal to it. So, but really I don't want my tool axis to be normal because I'm using a saw, and the saw is already rotated by 90 degrees. So I want my tool to go up and down like this to machine this, right? In this direction. I want my tool. So this blue has to go point in that direction.
Yeah, it's got to be perpendicular to that, basically.
Yeah, so I'm just going to rotate by the y-axis 90 degrees. So yeah, that's the orientation I want. I want my orientation this way. Okay, so once I got that, that's how I'm going to generate. So I go to 2-axis, saw machining, select my curve. I'll pick that surface edge, and then generate. So I got that. Okay, the tricky part here is which direction is that's not going to cut. That's not going to work for me because I'm going to gouge that apart. So I want to flip that direction. So the way I do it is go in and go right of curves. I'll flip the orientation so I can go check that. So yeah, that's exactly what I want. So, but if I run the simulation, you'll see, since I just picked the curve, it's just going to cut like that because I'm just saying cut it on that curve. Which is, but yeah, I got to give it a depth now. So go back in there to parameters. I can just pick the depth from the top to the bottom, and I can go one full cut or multiple cuts if I want it. And the other thing you notice is,
oh, sorry, go ahead.
Yeah, the toolpath is kind of small here. It doesn't look right. The reason that does that is there's two modes of machining. One is the cut extents, whether you want to stop at the contact, or do you want to?
That's exactly what I was going to ask.
Okay. Yeah, because if you're trying to do a rip cut, yeah, you want to go saw center, right? But if you're trying to do something,
like if you're doing a pocket or something, you want to stop and chisel it out later, or hit it with an end mill or something.
Right. Yeah, you could do roughing with a saw if you like a pocket rough that. So. So now,
is there a way? I guess if I wanted, for some reason, I wanted to extend past or something, I would just make a curve that was the length I wanted.
No, you don't need to make a curve. I'll show you how to do that. You can go to entry exits. You can add a line and an arc, and then you can put an angle or 0 if you wanted to go. Let me do this first, and then you'll see it's extending. And if I want to go a little bigger, let's say I want to extend it by 1 inch, but I want to go 0 degree on the entry, and I'll say 2 inches if I want, and then I'm going to go 45 degrees just for the sake of saying. So this is going to extend by 45 degrees out, and this is going 0 degrees coming in.
Yeah, cool.
Then I can simulate that. Cuts that out.
Nice. That's cool.
Yeah.
Nice.
Okay, and then for the, go ahead.
Oh, I was gonna say, I think that kind of covers
yeah,
how we're gonna use the aggregate head.
Yeah. So the other side is very similar. You just need to figure out the which way the tool axis is going to be pointed, right? And then which direction. I'll show you how to do that. So. Okay, let's create a setup. So I want to machine that chamfer. So I'm going to create a setup here. The easiest way, again, is select that surface. And my tool axis is pointing normal, which I don't want. So in this case, I want my tool to go up in this direction. So I just want to rotate again by, let's say, y-axis by 90. Yeah, that's the direction I want. Generate. Okay, so tool is going to go up in that direction, the blue arrow. So I can just copy this sawing operation. If the chamfers are all the same, that's what it's the easiest way to do it. And then I just paste that operation, and I can rename it. Do something like that. And then all I do is remove all my control geometry, select that. And it doesn't matter whether you pick this surface edge or that surface edge, you can control it based on the site of cut. And entry exits, maybe we don't want those long entry exits generate. Okay, there you go. Let's see if the tool axis is correct. No, that's not going to work, so I'm just going to flip it. Go to left of curves, generate. Yeah, that's better. So
cool. Well, that's great. This proves that it can do what we need it to do. One other question, I think Kelly already kind of answered this for me. It sounds like probably the answer is probably no, but we did get a 3D model of our actual machine. It's a custom built machine in China. But they did provide like an accurate 3D model of the whole machine.
Okay.
And there's no way to use that in the simulation, is there?
We can use it. You're only going to be using it for 3-axis and indexed machining, right?
Basically.
Not for continuous 5. We have a machine tool simulation module. So I'll show you that. So we can load them. We have these different. Let's take a file. You kind of like yours is a head like a gantry, right? Like a gantry.
Yeah, it's a gantry. It's just like a basic gantry CNC, router bed table, but it's got the aggregate head and an active C-axis.
Okay, so we probably have.
Yeah, I was looking at these exactly where you're at now. I was looking at those different options. That's what made me think, oh, maybe they could use our 3D model.
Yeah, something like this, right?
Yeah. Yeah, it's about the same level of detail. It has the linear like rails and stuff like that, and it's about that same level of detail. It doesn't have the wires and things like that, but it has the mechanical portions and all that.
We really don't push this a lot because there's some it's not complete implementation because there's some 4 and 5 axis issues. We haven't really paid too much attention because people don't really want this. So for simple 3-axis, we can do it. But for, if you're doing aggregate head with saw blades and all that, we really haven't really tested it or not even sure if it's going to work.
It's probably not necessary. It's mostly out of curiosity, and I assume there'd probably be some added cost to adding that.
Yeah, right. Yeah, because we got to build the machine inside of our. It's kind of like building a post, so it'll be similar.
Yeah.
As far as the cost.
Got it. Maybe
something in the future. Yeah, we can do that.
Yeah. And to start with, we probably wouldn't worry about it.
Yeah. The way our system is going is, we are going to bring the entire environment into the product. So that's where we're headed. But that's sometime in the future, though. So.
Yeah. Okay. And does it help you guys? Say we do go ahead and have you guys. We buy this from you and you make us a custom post. Does it help you to have that 3D model
No,
as far as
no,
the
it
options?
doesn't help with the post at all. I mean, I mean, it's visualization purposes, it might, but for the post, we really would need your help. You know, there'll be a little bit of a back and forth between our post developers and you, just to make sure we get the post correct. So once it's done, we don't really need any sort of visualization after that. So.
Okay, got it.
Okay.
Cool. All right. Well, I think you pretty much covered everything I needed to know, so I appreciate it very much.
Okay. All right. Great. So, do you want Kelly to give you a call at some point?
I'll contact her because I'm kind of I'm out in the field right now and I got to do.
Okay.
I got some. This is kind of a crazy week, so I might contact her end of the week or next week.
All right.
Hopefully to get with my boss and run him through the options. I'm on the side of wanting to use Rhino instead of Fusion, so I'm gonna kind of try to sway it that way. But I know he's a little bit more of a Fusion guy, so we'll see.
Okay. All right. Okay.
I want to
convince
this. Yeah, me too.
Okay.
So
right,
I appreciate it. And do you mind shooting me an email with the link to this video?
Yeah, we'll do that. We'll take care of that. Yeah.
That'd be great. Thank you.
All right. All right, Matthew. Take care, both of you.
Thank you. Thanks.
All right.
Have
bye-bye.
a good one, guys.
All right.